since we're already done discussing the properties of solids, so now let's discuss the properties of water. So basically, the differences between the properties of solid and properties of water is a lot more to explain. Why? Because from its composition and its structure, it you can definitely know that the both state of matter is very different. So now in this discussion, we will be undergoing, or we will be answering what is the differences between the properties of solid and the properties of the water. So let's start. So in the properties of a water or liquid, there are I think terminologies to be unlocked. We have polar molecule, cohesion and adhesion, high specific heat, density, which is the greatest at the 4 degrees Celsius, universal solvent of life. Yes, because in the solubility processes, the process that we've eventually always using is the water, and we all know that all of the substances, even if it is a solid, it can be dissolved by the means of the water. That's why water is the universal solvent of life. Okay, let's proceed. So let's discuss first number one on the polarity of water. In a water molecule, two hydrogen atoms form with a single polar covalent bonds with an oxygen atom. I've already discussed what is polar covalent bond, but to a review. So when we say a polar covalent bond, it is a bond formed when in a shared pair of electrons are not shared equally. So meaning to say, in a covalent bond, as we all know, covalent bond is about sharing. So there are two types of covalent bond, the polar covalent bond and non-polar covalent bond. So when we say polar covalent bond, it is pertaining or explains with a bond that is formed when the shared pair of electrons are not shared equally. So always remember that one. If it is not shared equally, it is defined or described as a polar covalent. And water has its polar covalent bond. So it gives water more structure than other liquids because it explains that the oxygen is more electronegative with the region around oxygen as a partial negative charge. And the region near the two hydrogen atoms has a partial positive charge. So it's pertaining on the structure of a water, and it's pertaining on the charges that produces by the water, the partial negative and the partial positive charges. So a water molecule is polar molecule with an opposite ends of the molecule with the opposite charges. So meaning to say, in the structure of the polarity of water or in the water itself, we will be seeing a two opposite ends, and by the two opposite ends, it can be shown also two opposite charges. So either it is partial negative charges or either it is partial positive charges. So always remember that one and take note with that one. So water has a variety of unusual properties because of attraction between these polar molecules. So that explains the polar molecules. So that's why there is unusual properties that being produced in a certain attraction of the water because of the polar molecules. And what is this polar molecule? So simply to give you a simplest explanation about polar molecule, it is basically a molecule that has charge on one side of the molecule that is not cancelled out. So meaning to say, going back to my discussion a while ago, that the water has its own polar molecule, meaning to say it has opposite charges. So as we all know, polar molecule is a molecule that has charge on one side. So either the other side or either the other side, because it is opposite, partial negative charges or the partial positive charges. So the slightly negative region of one molecule are attracted to slightly positive region. So explains the structure, huh? This explains how how polar molecule will interact in the structure of the water. So each water molecule can form hydrogen bond with up to 4 neighbors. So from the covalent or from the polar covalent bond to the hydrogen bond. So can you observe the swift of using of bonds? Okay, let's proceed. So since I've been mentioning hydrogen bond, and it is very, very, very important in water, because in water, hydrogen bond is included in a sharing of opposite charges. So hydrogen bonds explains or holds water molecule together. Each water molecule can form a maximum of 4 hydrogen bonds. The hydrogen bonds joining water molecule are weak, about 1.5 or 1 in a 20th as strong as covalent bond. So they form, break, and reform with great frequency. So that's why it's very important to use hydrogen bond in a water, because it is the compatibility between the charges, or between the opposite charges, will eventually be the answer, or be the process of the hydrogen bond. So either way, either with the covalent polar covalent bond, or either with the hydrogen bond, it can be used in a certain water molecule, or in a certain sharing of molecule or polar molecule in a water structure. So extraordinary properties that are result of hydrogen bonds, either it is cohesive behavior. So I've always mentioning what cohesion, cohesive. So what is this kind of behavior? Sorry. So literally the opposite of cohesion is adhesion. So cohesion is a property of like molecules of the same substance, take note, to stick to each other due to mutual attraction, while adhesion is the property of a different molecules or a surface to cling to each other. So can you observe what is the differences between the two? Because cohesive behavior or cohesion is the property or the very opposite of the adhesion. So cohesion, the same substances; adhesion, different substances or different molecules. Okay? I hope you understand it well. What is the differences between cohesion and adhesion? So resist changes in temperature. That is actually one part of hydrogen bond. High heat of vaporization, expands when it freezes, and versatile in solvent. So that explains why hydrogen bond is very important to the structure of the water. So it can help to boost the characteristics of a certain water. Okay, of a water itself. Okay, let's proceed. So organisms depend on cohesion, meaning to say on the same substances that will stick to each other because of a mutual attraction. So cohesion is responsible for the transport of water column in the plants. So cohesion among water molecules plays a key role in the transport of water against the gravity in the plants. While the opposite, or in contrast of cohesion, we have adhesion. The purpose of adhesion is to a clinging of one substance to another. So it contributes also in a water adheres to the wall of the vessel. So aside from cohesion, of course, adhesion is a part also in a hydrogen bonds or in a water. So always remember, hydrogen bonds hold the substance together. So the phenomenon of it is called as a cohesion. Kasi it explains the same substances that stick to each other and stick to each other due to a mutual attraction. Okay? So that is hydrogen bonds, or it explains more in the cohesion process, or the process of cohesion. Okay? Let's proceed. So another processes in particularly on water is surface tension. We've already know what is this process. Surface tension is very known in the different experimentation pertaining to water. So it is a measure of the force necessary to stretch or break the surface of a liquid. It is related to cohesion because it is the same substances that stick together and due to a mutual attraction. Water has a greater surface tension than most other liquid because hydrogen bonds among surface water molecules resist, stretch, or break the surface. That explains well why hydrogen bond is related to a water. Water behaves as if covered by an invisible film. Some animals can stand, walk, or run on water without breaking the surface, and the figure here, or the picture here in my PowerPoint, is a good example of an animal that can walk or can stay in the surface of the water. So that explains how the surface tension, or the process of surface tension, involved in the water, or why water has its surface surface tension. Kung bakit meron siyang properties like surface tension. Okay? Next, moderate temperature on Earth. This is basically on the table or the scales pertaining on the temperature of the Earth. How the water stabilize in air temperature by, of course, by absorbing heat from warmer air and releasing heat to cooler air. Water can absorb or release relatively large amount of heat with only slight change in its own temperature. So the table below will explain the moderation of temperature on the Earth. So this is the Celsius scale at sea level. Sea level ito ha, 100 degrees Celsius, water boils. 37 degrees Celsius, human body temperature. 23 degrees Celsius, room temperature. And 0 degrees Celsius is pertaining to water freezing. Okay, so there are some questions here that being actually arising. Here in this slide, we have what is kinetic energy, what is heat, temperature, a calorie, what is the differences in cal, and of course the capital cal and the small cal, what is the difference of it, and what is the specific heat. So we will be answering all of that in further discussion in general chemistry. But before, let's move our slide. So now, the last question that is being arising is what is specific heat. So specific heat is the amount of heat that must be absorbed or lost for 1 gram of a substance to change its temperature by 1 degree Celsius. 3/4 of Earth is covered by water, so the water serves as a large heat sink responsible for. So there are three statement that explains the specific heat. Prevention of temperature fluctuations that are outside terrain suitable for life, coastal areas having a mild climate, and a stable marine environment. So that explains more on how can we get a specific heat, or it explains more about the quantity of the heat required to raise the temperature of a substance. So or literally, when we say specific heat, to explain it more, it is a unit of it is usually use calories or joules per gram or per Celsius degree. So what are the examples of specific heat of water is 1 calorie. So I've already mentioned it a while ago. So yeah, so when we say specific heat also has a certain calculation. So upon our discussion, we will be discussing also more that one in our discussion in general chemistry about calculation. Kasi the differences between general chemistry 1 and 2 is more on calculation and more on application, while that 1 is more on content and more on factual events. So let's proceed. Evaporative cooling. So the cooling of the surface occurs when the liquid evaporates. This is responsible for moderating Earth's climate, stabilizes temperature in aquatic ecosystem, preventing organism from the harm, of course. So evaporated cooling is the one who can stabilize or balance the liquid. Okay, balances or stabilizes between the temperature of of the ecosystem or of the environment. So that's why it's called cooling. So it occurs, of course, eventually in the liquid. When the liquid evaporates, evaporative cooling will be found, or the process which evaporating cooling is involved. Okay, so let's proceed. Density of water. So most dense at 4 degrees Celsius, contracts until 4 degrees or expands from 4 degrees Celsius to 0 degree Celsius. So there are 3 statements also that discuss the density of water. Prevents water from freezing from bottom to up. Ice form on surface first. The freezing of the water releases the heat to the water below, creating a insulation. And lastly, makes transition between season less abrupt. So basically, when we say density of water, it is around approximately 1 gram per cubic or centimeter. Okay, so that explains the density of water. Okay, so pure water eventually has a highest density. Like, to be exact, we have 1,000 kilogram per meter in the pure water. So always remember that one. So that explains what is the density of water. It involves also a calculation. So I will be not mentioning that one kasi here I will be introducing you pa lang to the properties of a liquid or a water. But eventually we have a certain topic pertaining to density of water that explains the calculation or how can we calculate the density of a water. Okay? So if you have question clarification, you can ask me directly by messaging me in Facebook, or you can send me your email. You can send me a question on email. Okay? Next, when water reaches 0 degrees Celsius, the water becomes locked into crystalline lattice, with each molecule bonded to the maximum of 4 partners. As ice starts to melt, some of the hydrogen bonds break and some water molecules can slip closer together than they can while in the ice state. So it eventually explains how the ice will become a liquid water. Okay, so from the process on the melting point and using a hydrogen bond breaks, so that explains how it's formed. How can ice can be formed into a liquid water, or how can a liquid water can be formed into an ice. Okay, take note with that. And lastly, for the solvent for life. So why it explains a while ago, I've already gave you an explanation why a water or a liquid stay liquid can be explained as a solvent for life. Solution, solute and solvent. Aqueous solution and hydrophilic, which is ionic compounds dissolved in water. Polar molecules are generally water soluble. So in solution or in a solubility, we will undergo in the process from dividing the solute and the solvent. And as we all know, when we say solvent, it is the process on which the dissolving part, the dissolving state, while the solute, it is the substance that being dissolved, right? So that's why the water called as the solvent for life, because water is always used in dissolving a certain substance, either it is solid. Okay, so either it is all of the substances, liquid is the one who can dissolve it, so that's why it's called solvent for life. And hydrophobic or non-polar compounds. So most biochemical reaction involves solute dissolved in water. There are two important quantitative properties of an aqueous solution. We have concentration and the potential hydrogen. So this two is very important on the quantitative properties of a aqueous solution. So when we say concentration, it is the act or the process by which it has an abundance of a constituent divided by the total volume of a mixture. So that explains what is concentration. Basically, it's measure of how much of given substance there is mixed with another substance. So that explains concentration. While potential hydrogen is basically on the measurement of how acidic or basic is water is. So potential hydrogen is used for us to know if water is acid or basic or base. Okay. So eventually in potential hydrogen there is a specific range or a scale that we will eventually know on why the certain substance is acid, or why the certain substance is a base, or why this substance is neutral. So that explains potential hydrogen. It will measure the acidity and basicity of a certain substance. Okay? And let's go now on the concentration of a solution. So molecular weight is the sum of the weight of all atoms in a molecule daltons. Mole is an amount of a substance that has a mass in a grams numerically equivalent to its molecular weight in daltons. And that will arises the Avogadro's number, which is has explains the 6.02 times 10 to the power of 23, which is scientific notation. It explains that this Avogadro's number basically explains how you can write the very very large number and how can you can write the very very small number. Okay, that it can help us to write a certain number that in a very very large number, or either it is in very very small number. So a mole of one substance has the same number of molecules as a mole of any other substances. So that is the concentration of solution. There are different mentioned terminology here. So I will be basically discuss it in our next discussion kasi this part is pertaining on is focused on calculation itself. So I will not be discussing it furthermore kasi I will be discussing it on the topic which is concentration of solution. I'm just introducing it to you for you to know what is for you to have a hint what is concentration of solution. So let's proceed now on the dissociation of a water molecule. So occasionally it explains how the hydrogen atom shared by the two water molecule then shift from one molecule to other. So this is eventually explains the different part here. We have hydrogen atom leaves its electron behind and it's transferred as a single proton. That's why it's called hydrogen ion with a positive charge because it uses a positively charge. The water molecule that lost a proton is now a hydroxide ion and it is can use in the unit which is OH negative because once once there is a transfer of a certain proton, meaning to say the charge will be positive, while if you lost a certain proton, meaning to say your charge now will be on negative. Okay, always remember that one. If sharing or transferring a proton, you can gain a positively charge, while in losing or in adapting a certain transferred proton, you will lose a proton and you will have a negative charge. Okay, so the water molecule with the extra proton is hydronium ion, or it basically form an H2O plus. Okay, so this explains in the area here that explains the structure on how the transferring of a proton and the losing of a proton from hydrogen ion to hydroxide ion to hydronium ion. Okay, next, a simpler way to view this process is that the water molecule dissociates into a hydrogen ion and hydroxide ion. So that is a constant formula in dissociating a hydrogen ion from to hydroxide ion from positively charged to negatively charged. This reaction is reversible. So at equilibrium, the concentration of a water molecules greatly exceeds that of the hydrogen or hydrogen ion and the hydroxide ion. In pure water, only one water molecule in every 554 million is dissociated. So at equilibrium, the concentration of the hydrogen ion or the hydroxide ion is 10 to the negative 7 mole. So 25 from degree Celsius. So that explains how water can dissociate. So imagine from 554 million, the only one molecule will be dissociated. Okay, in a pure water. Always remember that one. So let's proceed. So this is basically a not a review, a hint for our next topic from the concentration of solution to acid and bases. So an acid is a substance that increases the hydrogen ion concentration in a solution, and a substance that reduces the hydrogen ion is called as the base. So we also have a strong acid and bases, complete dissociate in water. Weak acid and bases dissociate only partially and reversible. So we also have a strong acid and weak acid, and we also have a strong base and weak base. Okay? So that eventually describe the acid and base topic. So if you have question clarification, this also will serve as the coverage of the exam. And thank you very much for your for your time to listen this pre-recorded video. So I hope you will be listening it and watching it on my channel. So have a nice day and God bless everyone.